Chapter 3.4, Day 2, we're looking at the quadratic formula, and today we're specifically going to focus on the discriminant. So remember that standard form of a quadratic, because I know there's lots of standard forms, but we're looking at the standard form of a quadratic, is 0 equals ax squared plus bx plus c. That helps us with the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So in looking at that, I want to go back to this problem here. Use a quadratic formula to write a quadratic equation that has a given solution. So what we want to do is we want to get to ax squared plus bx plus c equals 0 from this equation here. So it's already plugged in for us and a little simplified, and we want to try and figure out what is a, b, and c. So the first thing that you can do is write the quadratic formula next to it. Negative b plus or minus the square root of b squared minus 4ac all over 2a. The next thing is just set pieces equal to each other. So I know that negative b and negative 4, those are related. So let me write that. Negative b equals negative 4, or b equals a positive 4. Then we can do that with the denominator. We have negative 14 and 2a. That's pretty fast to figure out. So this is negative 14 equals 2a divided by 2. So a equals negative 7. Now the last piece we have is the inside of the square root. And so just to kind of talk about vocabulary words, that's called the discriminant, what is inside here. So b squared minus 4ac, that is the discriminant. And in this case, it equals at negative 124. So negative 124 equals b squared minus 4ac. Now we wanted to solve for b and a first, so that way we're only solving for the c value. So let's plug in what we know. Negative 124 equals b squared, so that is 4 squared equals, and then minus 4 times our a value. Our a value is negative 7, and then we want to solve for c. So negative 124 equals 16 plus 28c. Solve for c, so subtract 16 from both sides. This is negative 140 equals positive 28c. Then we divide by 28. So we find that c equals, 28 goes into 140, that goes exactly 5 times. So c equals negative 5. So now we can write the equation. So ax squared, so this is negative 7x squared plus 4x minus 5 equals 0. And so that's how you would do that problem. So write the quadratic formula next to it, and then set each piece equal to each other to try to find what a, b, and c are. And then it's important to note that for the homework, you have to write equals 0 when you type it into big ideas. So let's take a look at the discriminant. So the discriminant is what is inside the square root here. b squared minus 4ac. So you can analyze the discriminant of a quadratic equation to determine the number and type of solutions of the equation. So when the value of the discriminant, what's inside the square root, is greater than 0. So if you notice, like in here, if that is like 5, for example, so square root of 5, we would get 2 solutions because it's whatever plus or minus that square root of 5, so you get 2 real solutions. And notice what I want you to see on that is that I have 2 x-intercepts. That is what it's really telling us. We have 2 x-intercepts. Then for the next one, so greater than 0, what we can look at is when it equals 0. So if that equals 0 inside the discriminant, that's going to be plus or minus 0. So adding or subtracting 0 is nothing. And so all we're looking at is the negative b over 2a. So this becomes 1 real solution. And notice that it hits the x-axis at exactly 1 spot. The vertex is on the x-axis there. Now the last thing we're going to look at is when the discriminant is less than 0. So for example, if it's inside the square root, you get a negative 36. Remember that it becomes a 6i. And the I equals the square root of negative 1. And remember that the I is an imaginary number. So we get plus or minus whatever value that is. So therefore we have two imaginary solutions. And notice it just doesn't hit the x-intercept at all, right? It's floating there. It could be up, pointing up and not touching, or opening down and not touching anything. So we have no x-intercepts.